Hey everyone, welcome back. So we're going to be solving another question today. Uh, the thing is, I've not solved this question before. So if you look at my submissions, I don't have any prior submissions to this, right? I'm going to be solving the question with you. The reason I'm doing that is because let's say you're stuck at a point and you're not able to figure out how to move forward, and that's why we come to YouTube to check out the videos, right? So if I was stuck at the same point and I try to figure it out, if I do, it'll be helpful for you to know where you're going wrong, right? And that is the reason I'm planning to do this. Okay, it might take a lot of time because I've not solved this problem before. I'm going to be doing it with you, right? So let's get started. Let's try to do it together. Let's try to do it like a pair programming, right? You can do it with me. You can think about it with me, right? So let's get started. The question is fairly simple, as in the statement of the question is simple. You're given a grid and you have to find the minimum path sum to reach the destination from source, right? So your source is nothing but the starting point and the destination is nothing but the bottom right of the array, right, of the grid, right, which is nothing but one. This is source, and then this one is a destination. So you need to find the minimum path sum, right? Okay. So before we get started, there are few terms that you need to understand to at least approach the problem. Okay. There's something called as a top-down approach, right? And then there's something called as a bottom-up approach, right? Okay. So what's a top-down approach? What's a bottom-up approach? It's the same thing as the name, right? What are you doing in top-down? You're moving from top to bottom, right? By that, what I mean is, you're trying to break a big problem. You're taking a big problem, you're breaking it to smaller problem until you reach some condition so that you can return it back, right? That's what a top-down approach is. So if you've done recursion before, let's say Fibonacci series of 5, what do we do? We take Fibonacci series of for 5, what we do, n minus 1 and then n minus 2, right? N starts with 5. So that's a bigger problem, and then we're breaking it down into small problem until it's a base condition. That's a top-down approach. What's your bottom-up approach? It's the opposite thing, exactly the opposite thing. But now what I mean is, you're starting from a small problem, building it up to the to solve the bigger problem, right? So it's as simple as it sounds, right? So at least for my understanding is that if you can get a top-down approach, right, for a problem, the core part of the logic will still remain the same, right? Only the base condition for the bottom-up problem will change a bit because you have to start from the beginning, right? So you need to have some initial values to start. Perfect. So what we're going to do is, top-down approach is the one which is very interesting, which is very it's very interesting. So we're going to be doing top-down approach, right? We're trying to figure out how it's done, right? And let's get started. Okay. So the question states that you have to find the minimum path sum. Before we go to minimum path sum, let's figure out how many paths are there to reach this particular destination. So there's one condition given: you can only move towards the right, or only you can move down, right? You cannot move left is not possible, and up is not possible, right? With that in mind, what are the number of paths? So either you can move like this, right, or you can move down, you can move right, you can move down, you can move right, or you can move down, you can move right, you can move right, you can move down, right? Or you can move down, right, you can move down, you can move down, you can move right, or you can move right, you can move down, you can move right, you can move down, right? Or you can move down, you can move down, you can move right, you can move right. Okay. Or you can move right, you can move right, and then you can move down. Okay, this path is already covered. You covered this one. Okay. Now, with this in mind, we have to find the minimum path sum, right? Okay. Let's think about it. Okay. So let's just say that instead of this question, the question is a bit different, asking you to find the number of ways that you can reach one from this source, right? How would you do it? Consider it top-down approach. how do we start with the top-down approach? We'll start from the destination itself, and we'll try to figure out how many ways are there to reach that destination. Right? So let me mark this index as well. 0, 1, 2, and 0, 1, 2. Right? So basically, the ways of reaching 0, 2 and 2 has 2 ways. Right? What are those 2 ways? It's I need to let I think this should be good. Let me erase this as well. Okay, this should be good. Okay, so how many ways do we have? We have already seen that visually, right? But let's look at it in a logical way. Ways to reach 2, 2. Either you can come from 1, 2, because you can move down, or you can come from 2, 1. 2, 1. Yes, you can move right. So ways of reaching 2, 2 are 2. Way of reaching 1, 2, or way of reaching 2, 1. Okay. Why am I stressing on or? Because it is a number of ways that you can reach, right? So obviously it's an addition, right? Either you can move this way or you can move this way, but you can move either of the ways, right? Total number of path would be an addition of that. Okay. Similarly, what is a way to reach 1, 2? 1, 2, right? That is 1. Simple. Way of reaching 1, 1, that is this one to this one, right? Plus way of reaching 0, 2, right? Perfect. Similarly, what is a way of reaching 2, 1? Way of reaching 2, 1 is way of reaching, you can move only right. You can move down also, my bad. Way of reaching 2, 0, or way of reaching 1, 1. Right? 2, 1. Okay, perfect. Similarly, we will keep going until we hit a base condition. Okay, and that base condition would be either if the row is 0 or the column is 0. There's only one way you can move, right? Because if you have to find the number of ways to reach 1 from this one, what would you do? You cannot move up, so you can only move in this direction. So there's only one way to reach it, right? If we consider 4, what is the number of ways? You cannot move left, so you can only move like this, right? Now, so the base condition would be either when if row is 0, column is 0, I would return 1, because that is the only way to reach it, right? Perfect. Now, again, I'll keep going, and then you will trace it back, and then you will get the final answer, number of ways to reach 2, 2. Okay. The reason I'm showing you this is, first thing I want to show you how a top-down approach works, and second thing is we're going to be using the same approach for this problem as well, trying to use the same approach for this problem as well. That is the reason I wanted to show you this. Okay. Now, okay, I'm not going to go through the entire thing because that's not what the problem is, but I would suggest you to pause the video, do it on your own, and then come back to this so that you get an understanding on how this works, how a recursive call works, like from a top-down approach, right? Okay, let's come to this problem now. Let me make another diagram. Right, so I have 1, 3, 1, and then I have 1, 5, 1, and then I have 4, 2, 1, right? So I have to reach my 1 from this source. Perfect. Okay, now let's think about it the same way. Minimum path sum. Okay. First, we need to know if that's a legit path. If that is a legit path, we need to consider the minimum sum of that. Okay. That is the idea. So first, it should be a legit path. Right. What I mean by a legit path, you can only, to reach that point, you can only move right or down. Right? That is the first statement. What is the second statement? After it's a legit path, take the minimum of that, minimum of the path. of the legit path, right? This is my idea that I'm going with. From here on out, I will have to figure out each of the things because I don't know, I've not solved this problem. But this is the idea that I'm going with. Let's see if it's correct or not. Okay. So what I'm saying is it has to be a legit path. By legit path, what I mean is either I can move like this or I can move like this. Right? Then take the minimum of the legit path. By that, what I meant is, see, if I'm coming like this, right? Let's consider only this particular part of the array. Only this particular part of the array. Okay. There's no more. There's nothing more than that. Okay. No, actually, let us only consider this part of the array. Okay. Let us assume that there's nothing more than that. There's no more than this. Okay. Now, to reach 1 from 5, what are the paths that I can take? I can either take 1 or 2. If I consider 1, okay, my total sum would have 1, okay? And then of course 5 because that is the source, plus 5 source. Okay. If I consider 2, right, that is also a legit path. My total sum would be 2 plus 5 is 7, right? So when I took the path from 1, my total sum is less than the path that I took from 2, obviously, because 1 is smaller than 2, right? So, okay, from here I can make a observation that it's a fairly simple observation, but an observation that once it's a legit path, I need to consider minimum of those two paths, right? There can only two paths, left or right, right or down, right? And I should consider the minimum of those two paths. Okay, perfect, I know that. Okay, now let's remove this. Okay. Now minimum sum path, sum of reaching of reaching 2, 2 is of reaching 2, 2. Okay, I am not going to go to 2. I'm only considering 1. Okay. There's a term called as pruning. I don't know if you guys know this. It's a concept in backtracking. Basically, what do you do in backtracking? You backtrace the problem, right? When you're backtracing the problem, okay, you ideally skip something for which you know that you're not going to get the answer, right? Or you're not going to consider it. So what you're doing, you're pruning it, right? You're ignoring it, or you're not even going through that path, right? So that is what pruning is, and this is kind of similar to that, right? Because we're not considering 2, we're only considering 1. Okay. So perfect. Ways of reaching this thing is ways of reaching 1, 2 is the only way, right? This particular path got pruned, meaning this particular path got ignored because it is the largest sum. Okay, perfect. Now okay, now ways of reaching 1, 2. Let me draw it over here actually. Okay, now I've reached 1, 2. Okay, so I'm currently at this point. This particular point, right? So how many ways are there to reach this path? It's this one or this one, right? So here what I'm going to do is I'm going to consider the path ways of minimum sum. It's actually not this, it's minimum sum, minimum sum path till 1, 0, 1. 0, 2 actually, because I'm considering this path 3. Perfect. minimum sum of 0 comma 2. Okay, now what is the minimum path sum to reach 1, right? We have to calculate it because in the ways like in this one that we did, we didn't have to calculate it for this row or this particular row or this particular column, because this particular row or this particular column, because there's only one way to reach that path, but there's not number of ways, there's a minimum path sum. So I need to know the sum to reach this path, right? Okay, so what would I do? So minimum sum to reach 0 or comma 2 is ideally either from this one or nothing, right? So there's only one minimum sum path to reach 0 comma 1. Okay, what is the minimum sum path for that? Minimum sum path to reach 0 comma 1 is minimum sum path to reach 0 comma 0. Okay, what is the minimum sum path to reach 0 comma 0? It is 0, right? So when it hits 0, what I can do is I can start returning. Okay, wait, when it hits 0, do I start returning 0 or do I consider the, you know what, I can do something different, a bit different over here. I'll make a call, but I'll also keep the values. Okay, so it'll be minimum path to reach this will be 1, 4, 5, 6, 7, right? So this also included, right? So minimum sum path to reach 1 comma 2. So this will be 1 plus minimum sum path to reach 1 comma 2, right? Minimum sum path to reach 0 comma 2 would be again no wait, yeah, 1 plus this thing, right? Here it will be minimum sum path to reach 0 comma 2 will be again 1 plus something, right? Minimum sum path to reach 0 comma 1, 0 comma 2, yeah, will be 3 plus 0 comma this thing, right? Path to reach 0 comma 1 is 1 plus path to reach 0. Once I've reached this, what I'll do is I'll start returning 0. Once I've returned 0, this will be 1 plus 0 and this will return me back 1. Okay, minimum sum path to reach 0 comma 1 would ideally have 0 comma 1 would be 3, right, which is 1. So minimum path sum is 4, right, because it's 3 plus 1, 4. So I'll return back 4. Okay, minimum path sum to reach 0 comma 2, 0 comma 2 is 4, right? If you look at it visually also, it is 4 only. 4 plus 1, right? So ideally this will be 1 plus the same. Okay, so 4 plus 1, right? So 4, 5. Yeah, right. So it is. So the minimum sum path is so what is the path that I can reach this one, right? I can either come like this or I can come like this. But what is the minimum path? Minimum path would ideally be like this. Oh, sorry. Minimum path would ideally be like this, right? It won't be like this because there's a 5 which is gonna increase the sum. Okay, so perfect. I got 4. So minimum sum path to reach 0 comma 2 is gonna be 5. Minimum sum path to reach 1 comma 2. Oh, right. Sorry, that was for 0 comma 2. The same thing, right? What is the minimum sum path? Okay, right. Now, what is the minimum sum path that I can reach 1 comma 2? Right? It's the same thing, right? Either I can go like this, okay, or I can go like this. I'm choosing to go like this because this path will be much more sum, right? Because it will be 1 plus 1 2 plus 5 7 plus 1 8, right? Here if you consider, it is 1 plus 3 4 plus 4 plus 1 5 5 plus 1 6. Since it is smaller, perfect, we're going in the right direction. So this will be 6. So what will I do? I'll return 6. right? And minimum sum path of reaching 2 comma 2 will be 1 plus 6, which will return me 7. Perfect. Perfect. Okay. Now let's look at the constraints actually. The reason I want to look at the constraints is, okay, m comma n is less than or equal to 200. Okay. I'll tell you why I'm looking at the constraint. That's actually very interesting. But you know, for now, let's just go with this. Okay, let's take another example actually. Okay, let's consider this example, the second one. So 0 1 2 0 1 2, right? So you have okay, it's only 2. Okay, so it will be 1 2 3 4 5 and 6. Okay, minimum sum to reach 6, right? Let me bring it down over here. Perfect. So this is my destination, right? And this is my source. Perfect. Okay, what are the paths that I can take? For minimum path sum of 2 comma 2 will be either sorry, 0 and 1, right? Okay. It's not this thing, it's minimum path to reach 1 comma 2. Okay, it's either there are two ways, right? Either to find the minimum path sum, this will be 6 plus, right? Minimum path sum from 0 comma 2, or minimum path sum from I'm just writing a minimum, but it's actually minimum sum, right? Or from 1 comma 1, right? So these two are the ways I can reach. Okay, what I'm going to do is I'm going to prove this because this value is greater than this value, right? So I'm now going to go through this path. Okay, I'm going to go through this path. Minimum path of reaching 0 comma 2. Okay, 0 comma 2 is ideally there are two ways to come from minimum of 0 comma 1, or from minimum of minus 1 comma minus 1 comma 1. Okay, ideally. Okay, I know this is wrong because minus 1 is out of index, but so this would just break and this will just return 0, right? Because you cannot reach this thing. Okay, now ideally, okay, let's look into that. Okay, path of reaching 0 comma 1, right? Yeah, the reaching 0 comma 1 would ideally be two ways: minimum of reaching 0 comma 0, or minimum of reaching minus 1 comma 0, right? This path is not valid, so forget this. Okay, now I've reached 0. Okay, oh, I forgot one more thing. 0 comma 2 will ideally be 0 comma 2 will ideally be 3 plus 0 comma 2. 0 comma 1 will be 2 plus 1 comma 1 plus. When you're making a call here, this will break and this will return 0. Once it's returned 0, what we're going to do is we're going to return 1 to this particular function, right? Okay, we got 1, so 2 plus 1 is 3, we're going to return 3, right? 3 plus 3 is 6, we're going to return 6, and 6 output is 12. Is that the answer? Yes, that is the answer. Okay, if you've got an idea, so what are the conditions? The first condition is to prune it, right? Okay, we're going to take minimum of that plus minimum of row minus 1 column right, comma, uh, keep row and then column minus 1. Okay, this is how our pruning logic would work. Okay, okay, perfect. We have to handle the edge case where it is going out of bounds. Let's do that, but let's try to start solving. Okay, perfect. What we're going to do is we're going to write another function. I'm going to call it public int minimum sum of int array and then int row and then int column. Okay, if row equals to 0 and my column equals to 0, what I'm going to do is I'm just going to return 0. Perfect, that is done. Now the other condition is where this thing comma 0, 0, 1, 0, 0, or okay, now it's going to be 0, right? Do I really need to prune it, or can I go ahead with taking a minimum value of that? Okay, let's think about pruning a bit later. If my row is less than 0 or my column is less than 0, what I'm going to do is I'm just going to return 0, right? My sum would be, right, array of row and column plus math dot minimum of min sum of right, array comma row minus 1 and then column, or minimum sum of array of keeping row column minus 1. Okay, I can either return sum or I can just return this. Okay, now I'll just return so int row is grid of 0 is grid dot length, right? And int column is grid of 0 dot length. Now return min sum of, I'm gonna pass this grid and then I'm gonna pass this row and then I'm gonna okay, this will be minus 1, right? And this will also be minus 1, right? And then I'm gonna pass my column. Would this work? Let's think about it. What am I doing? I'm not pruning it because I'm just taking the minimum sum after calculating it. But would this work? Let's try it out. Let's run it and try it out. Okay. Okay, we got an output of 3. Okay. What am I missing over here? So I think what's happening is, if you're considering, okay, okay, I think I know what's happening. So you have 1, 2, 3, and then 4, 5, 6, right? So when you break it down, right, what's happening is, from 6 if we go, I can either go 5 or 3, right? So I'm going to take the minimum of that, right? So 6 plus sum of 5, I'll take 3, right? And then I'll go to 5, right? And then what's happening with 3 is, you cannot go, you can go only one direction, that is sum of 2. With 2 also you can go only one direction, and then you go with sum of 1, right? This will return me 0. Okay, okay, this return me 0. Okay, so I'll make it return array of row and column. Okay, now this will return me so 3, right? 3 plus sum of 3, and 2 plus sum of 2, and then 1 plus sum of 1, right? uh, so 0, 0. Oh, okay, this will hit the base condition, so this, it won't even come here, right? Because the base condition is over here, so it would return this thing. So I will make it return 1, right? And then 1 plus 2, okay, will be 3, right? 3. But over here what happens is, another one gets called sum of 3, right? So basically you have 0, 1, 2, and then you have 0 and 1, right? So sum of 2 will be called, that is of sum of 2. I'm just going with the values, okay? Please don't get confused. Okay, sum of 2, right? And then you would go with, for 3 you went with either 2 or you would go with you go with 2. Yeah, that's the only way, right? Because the other one would return. Okay, okay, I think I get what's happening. The other one would be out of bounds, right? Because if you think about it, for 3, either you can come like this or you can come like this, right? But this is not valid. Okay. Valid, right? So sum of like invalid would give, sum of invalid would return me false. I'm making it return 0, right? So what's happening here is, this is returning 0, and it's taking the minimum of these two, which is 0, and then it's returning 0. Okay, and then it's returning that 0 value, and it's returning me 0 value, and because of which, okay, it's throwing an error. Okay, let me do something. What I'm going to do is, this is 2, right? And this is basically an invalid index, right? So when it's an invalid index, what I'll do is, I don't even have to consider this, right? If you think about it, if this is an invalid index, right, if this is an invalid index, I don't even have to consider this, right? So what I can do is, I'll need to only consider this part, right? Because this is not even considered. So whatever this sum is, that's what I need to consider, because that is the only path, right? So what I'm going to do is, here I'll just return integer dot max value. Okay, when I return this, when I return this, this will get returned, and okay, we don't need this. Okay, this will get returned. Perfect. Let me run it. I think this should go through. Okay, there is an error. Okay, it is also not required. Okay, perfect. I got accepted. Now, if I try to submit this, okay, there's a small issue. Okay, let me show you that. Okay, so if you see, I got a time limit exceeded. Okay, so here is where it gets very interesting. Okay, the reason I got time limit exceeded is you're making a recursive call uh, for every single index, right? How are you making a recursive call? For 2 comma 2, you're making a recursive call to 2 comma 1, and from 2 comma 1 you're making a recursive call to uh, uh, you're making a recursive call to uh, 1 comma 2, right? And for 2 comma 1 there'll be two values, some values, and then there'll be some values over here, there'll be some values over here, there'll be some values over here. So if you think about it, it is 2 power 0, 2 power 1, 2 power 2, and goes on till 2 power n plus m, or 2 power n plus m, 2 power n into m, right? Right, 2 power n into m, or 2 power n plus m, if let's think about it, because it's gonna make a recursive call. It is 2 power m. Okay, you're basically taking the minimum value, right? Okay, so if you keep on going, it'll be 2 power m plus n, right? Why? Because every time you're splitting and then you're considering, so basically for a path, I'm either taking this side or that side, right? Or I'm taking, for one, I'm taking either this can be the minimum path or this can be the minimum path. Okay, that's what I'm considering. And for that, the time complexity will be 2 power n plus m, right? Because it's a ideally 2 power n for a normal array. Since it's a grid 2D array, it'll be 2 power n plus m. Okay, perfect. This is why you're getting this error, right? So if you think about it, your n value ranges to 200, right? So it will be 2 power 200 plus 200, 2 power 400 will be, right? 2 power 400 is a very huge thing, right? This is where we need to think about optimization, right? So most of you who are doing DP might find it a bit difficult on why we need to use DP or how can we use DP. This is exactly where you need to use DP. Okay, so let's just think about it logically. Okay, in this particular problem, right, what am I doing? Right, for 2 comma 2, I'm going to 2 comma 1 or 1 comma 2, right? For 2 comma 1, what am I doing? I'm going to 1 comma 1 or 2 comma 0, right? 1 comma 1, what am I doing? 1 comma 0 or or 0 comma 1, right? And then for 2 comma 0, what am I doing? I'm going to 1 comma 0 or it'll be this won't be valid, but it's okay. It'll be 2 comma minus 1, right? This is not valid. Okay, I'm just showing it to you for reference, right? And then for 1 comma 2, what am I doing? I'm going to 0 comma 2, right? And then I'm going to 1 comma 1, right? So if you think about it, this is a small value, right? If you think about it, do you see that these particular recursive calls are getting repeated again and again, right? So what we're doing, we're calculating it once, again and again we're calculating it, right? So we need to think about a way to optimize this. Okay, think about a way to store it somewhere such that it'll be easier for us to access it. By that, what I mean is, once I've come this way and I've calculated 1 comma 1, when I'm going over here, if I have this value, can I not just return the value? It would save us our entire job of making a recursive call again and again, right? If I have this value stored somewhere, okay, I can easily use this value and just return this value, right? So this is where we need to think about storing it, right? This is nothing but memoization. You're basically storing the value. That is the whole point. This concept is called memoization, and your top-down approach uses something called as memoization, right? Where you're storing the value so that you don't have to make a recursive call for the ones you've already made, right? So it's very simple. Okay, it's very simple. What I'm going to do is I'm simply going to create a new array. I'll call it dp equals to new int. Okay, and then I'm going to give I'm going to give grid.length only, length, and the columns would be grid of 0.length, right? Perfect. Now what I'm going to do is I'm going to pass this DP array as well. Okay, but now before we pass it, if you know in Java, whenever you initialize an array, right, 1D, 2D, all the values gets initialized with 0. Okay, now can a sum be 0? Of course it can be 0, right? So if I'm trying to fetch a stored value, how do I know that it is not stored or it is stored? By that what I mean is, how do I know that I've gotten 0? Okay, how do I know that this is a stored value or this is a default value? That'll create a confusion, right? So what we're going to do is we're going to iterate through these through this DP, right? And then for n j equals to 0, j less than dp of 0.length, and then j plus plus. And then what I'm going to do is simply I'm going to make it -1, because can a sum be -1? No. This is standard practice that I at least use, or I'm not sure if others use it. But what I'm doing is I'm going to set it to something that it cannot be. Can a sum be -1? Never, right? Unless until there are negative numbers. There are not negative numbers because you see it starts on 0. Okay. So here what I'm going to do is I'm going to pass it as a parameter, right? Okay, dp. Okay, and then here also I need to pass it as a this thing. Okay. Now what am I going to do? It's very simple. Okay. After this condition, what I'm going to do is I'm going to check if my dp of the given row or the given column is equal to -1 or not. If it's not equal to -1, then I know for a fact I have some value stored over there. Okay, I'm not storing it yet, I'll do that, but I know for a fact that some value stored over there. So instead of going through the below part, which is making a recursive call again and again, which is making a recursive call over here, what I'm going to do is I'm going to simply return my dp of row and column. Right? Perfect. Now we've done that, we need to store it somewhere, right? You see this int sum. Okay. Why do we have to have a sum, right? Let's just store it in our dp. Every time you calculate something, okay, so what does the dp hold? At a given point, at a given index, right, at I comma j, dp holds the minimum possible sum for that particular index, for that particular box of the grid, right? So if you see over here, so just to give you an example, if I'm storing dp of 0,1, what does 0,1 hold? The minimum sum to reach 2, that will be 3. So my dp of 0,1 will hold 3, right? That is what the dp is holding. Okay, so what I'm going to do is I'm going to do dp of row and then column equals to this thing, right? And then I'm going to return dp. Perfect, right? Return dp because dp of row and column, dp of row and column, right? Yeah, because this is an random type of int, and then I'm returning dp of row and column. Okay, perfect. Now let's try to run it. Let's see how it runs. Okay, let me use this test case. Let's see how it runs. Okay, I got an error. Okay, I need to pass it over here as well, right? Okay, what's wrong? Oh shit, passing outside. Okay, I think now it should run. Perfect. Let's try to submit it and let's see how it works. Okay. Perfect. Now let's analyze the time complexity. Okay, I'm saying that it will be O of n into m because you're iterating through only the elements of the grid, right? And then you're doing it only once, because once you're doing it, you're storing the value, and the next time you are going to that, you're accessing the value, and you're not going through the process of making recursive calls again and again. Okay, so ideally it should be n into m. Okay, n square. Okay, n square. Because this n square is the length, right? N into m. This is not a square matrix, so it has to be n into m. It's not n square, right? If it's a square matrix, it's n square. Okay, Perfect. I hope you understood this. This video is a bit long because longer than my usual videos, but I hope I made it clear. Please go through this on your own. Please try doing it on your own, and then yeah, you can comment if you have any questions, and I'll be very happy to answer. Okay. Thank you.